Okay, good morning once again, and today we are going to start with the topic triangles. If you have gone through the syllabus of class 9, that is the reduced syllabus of class 9, you must have observed in the chapter named triangle, we have the congruency of triangles and the rest to the isosceles triangle and the inequalities have been removed. So we are to do with only congruency of triangles. So let us, without wasting much time, let us start with the topic congruency of triangles. So before we can start with the topic congruency of triangles, let us first know what is a triangle. Note down.
Excuse me, sir.
A triangle, write down a closed figure formed by three intersecting line segments. A closed figure formed by three intersecting line segments is called a triangle. A triangle has three sides, three angles, and three vertices. This is just a definition of what is a triangle. Now if you see the word triangle, these three letters TRI, tri, which means three. So this name is given as triangles, three angles. So if you see to a triangle ABC, we have three angles as angle A, angle B and angle C. Also at the same time we have three sides AB, BC and CA and three vertices A, B, C. So you find that the number of vertices in the triangle is 3, the number of sides in the triangle is 3 and the number of angles in the triangle is also 3, and thereby the name triangle. Okay, now since the chapter, the name of this topic, today we are going to discuss about congruency of triangles. So before we can start and discuss about what are congruent triangles, let us first understand what are congruent figures. So let us get the concept of congruent figures. I will write some examples on the board which will give you a clear idea and the concept of what are congruent figures. Two passport size photographs. Two passport size photographs. Two chalks that I am writing with. Two 10 rupee coins. Then we can have the shaving blades of the same company. Six of the same letter pad. Then we can have biscuits in the same packet. Then we have two stamps of the same shape and size. Now what can we say about all these, what is written on the board? Two passport size photographs. When you go for passport size photographs, you find it that the two photographs, when one is kept over the other, that is when they superpose or when they overlap, they appear as only one photograph. That means they are equal in every respect. Similarly, two chalks, if I take these two chalks and if I keep it like this, one after the other, and it will appear to you as it is only one chalk. So that means the two chalks, they superpose or overlap completely and giving us an effect that there is only one chalk. So these two will be called as congruent figures, right? Similarly, if you take two 10 rupee coins, if the two 10 rupee coins are there and they are put one above the other, then you will find they completely overlap, giving us the conclusion that the two 10 rupee coins are also congruent. Shaving blades of the same company, if you take, they are also equal in every respect. Sheets of the same letter pad, if you got a letter pad and if you take out the sheets from there, all are of the same dimension, they are equal in every respect, so they are also congruent figures. Biscuits in the same packet, any brand biscuit you take and you take out the biscuits, you will find they are of the same shape and the same size, and hence we can call them as congruent figures. The two stamps of the same shape and size, any stamp, postage stamp that you collect from the post office or somewhere else, if they are of the same shape and shape size, we call them as congruent figures. So basically, what are congruent figures? Congruent figures are those figures which are exactly a true copy of each other. That means if we overlap one with the other, it will give an effect that there is only one such object present. So congruent figures, in short, we can say, are the figures which are having the same shape as well as the same size. Hope you understand this. Now we will extend this concept. I am rubbing the board now. Supposing we take two circles of the same radii, the radii are the same. That means if the radii are the same of the two circles, then if you put this circle on above this, that means if we superpose one above the other or we overlap the two circles, it will appear as only one circle. So if I put this particular circle on this, so this will give an effect of only one circle, which tells us that the two circles are congruent, that is, they are exactly of the same shape as well as of the same size. But if you draw this circle, if this is also a circle with a smaller radii, so this circle, this and this, they are not congruent figures, because though they have the same shape but their sizes are different. So in order that the two figures will be called as congruent figures only when their shape as well as the size both are exactly the same. So these two are not congruent, but these two are congruent exactly. If we consider two squares, let us take two squares and the measure of each side of the squares is the same. This square and this square, the sides measure the same, then these two are congruent figures. These two will be called as congruent figures because they have the same shape as well as the same size. That means we can say they are the true copy of one another. If you put this square above this, that is, if we name it as square A and square B, if you put square B above square A, it will appear as only one single square, indicating or giving us the conclusion that the two figures are congruent. If we take a smaller square like this, then this is, though the shape of this square and these two squares are the same, but the sizes are different. In that case, these two will not be termed as congruent figures. So now you have understood what are congruent figures. So now let us extend this idea and the concept further to understand what are congruent triangles, which is the topic for today. Now before that, supposing when are two line segments, when are the two line segments congruent? If we consider two line segments, one is this, let us name it as L, and another we take this line segment, let us take it as M. So these two line segments, you can see they are of equal length. So if two line segments are of equal length, then we say that the line segments are congruent. Okay, so if the line segments, both the line segments measure equal lengths, then we call them as congruent line segments. Other way around, we can say if these two line segments are congruent, then the lines are of equal length. So vice versa, if the lines are of equal length, they are congruent. If they are congruent, then the lines are of equal length. Similarly, if we take a smaller line segment like this, and this is N, so you can see the shape remains the same, but the size varies, the length varies. So this length and this length are not equal, so these two line segments cannot be taken as congruent figures. Okay, so similarly, when are two angles congruent? When are two angles congruent? So two angles are congruent when the angles made by the two line segments are equal. The angle made are equal. If this angle is theta and this is also theta, then we call these two angles as the congruent angles. So angle A, B, C, and if it is D, E, F. So if angle ABC is equals to angle DEF, and that is equals to theta, then the angles are congruent. Okay, so now you understand what are congruent lines, segments, what are congruent angles. Now let us get into the business of understanding what are congruent triangles and what are the criteria for fulfilling that the two triangles are congruent. Let us take two triangles like this. This is triangle A, B and C. This is P, Q, R. If we take it like this, and triangle ABC is congruent to triangle PQR. This is the symbol of congruency. Congruency. This symbol is to signifies that the triangle ABC and triangle PQ are congruent. Now what do we mean by congruency here in terms of triangles? Now if the two triangles are congruent, that means angle A and angle P are equal, angle B and angle Q should be equal, and angle C and angle R should also be equal. In the same way, the side AB should be equal to side PQ, side BC should be equal to side QR, and side AC will be equal to side PR. That means if you want to take this figure, shift this figure or superpose this figure or overlap this figure on this, that means take this triangle PQR and put it above ABC, then what happens? Then the point P, the vertex P, the vertices are A, B, C, and here the vertices are P, Q, R. Then the vertex P falls on A. If you superpose that, this will overlap with A. Similarly, Q falls on B and R falls on C. So that means these points A, P and A will overlap, Q and B will overlap, and R and C will overlap, and giving us the effect of only one triangle, that is they are equal in shape as well as in size. In the similar way, the side AB and PQ, if you consider, the side PQ falls on AB the side PQ falls on the side AB. Similarly, QR falls on BC and PR falls on AC, which means that this triangle and this triangle are congruent, and all the points, the vertices as well as the sides overlap. The final result is that the triangle will appear as a single triangle. So in the case of congruency of triangles, the two triangles are said to be congruent if they overlap exactly in terms of their vertices, in terms of the sides, in terms of their angles. Now the question is, why do we study about congruency of triangles? Can anyone tell me why do we study about the congruency of triangles? Anyone? No one? So why do we study congruency? This is because whenever identical objects like suppose this circle and this is another identical circle, the study of congruency is important in order to have identical objects, and we need to produce, this is one circle and we need to produce another circle of the same shape and same figure size. So for this particular cases, when you have to produce some identical objects, the concept of congruency comes into act. Okay, so now we will understand this with the help of some examples. Now before that, when we say the two triangles are congruent, write down incongruent triangles corresponding parts are equal. Corresponding parts are equal, and in short, we write CPCT, which means congruent parts of congruent triangles. So this is in short we write the congruent parts of congruent triangles, and we represent it in short CPCT. Sorry, this is just make a check. This is the corresponding parts. Corresponding parts of the congruent triangles. Now we will learn criteria for congruency of triangles. Criteria for congruency triangle means how can we prove that two triangles are congruent. So we have certain rules. So first one is S congruence criteria, or which we call as rule. If, write down, if under a given correspondence, if under a given correspondence the three sides of one triangle, the three sides of one triangle, if under a given correspondence the three sides of one triangle are equal to the three corresponding sides of the other triangle, then the triangles are congruent. So note it down, if under a given correspondence the three sides of one triangle are equal to the three corresponding sides of the other triangle, then the triangles are congruent. So if we take triangle ABC and another triangle, let us name it as DEF. So if side AB of triangle ABC is equal to the side DE of triangle DEF, that is, if AB equals to DE, the side BC is equals to EF, and the side AC is equals to DF. If this happens, then we say that triangle ABC is congruent to triangle DEF, and this is by SSS rule. So if you can prove that the three sides of one triangle are equal to the corresponding three sides of the other triangle, then the two triangles are congruent. So this is the rule number 1, or you can say the criteria. So moving on to the rule number 2. So number 2 is SAS congruence criteria or rule. So if under a correspondence two sides and the angle included, two sides and the angle included between them, if under a correspondence two sides and the angle included between them of a triangle are equal, to two corresponding sides and the angle included between them. And the angle included between them. Then we can say that the triangles are congruent. So if under a correspondence, two sides and the angle included between them of a triangle are equal to the two corresponding sides and the angle included between them of the, just add here, of the other triangle. Then the triangles are congruent. So I read it out once again. If under a correspondence the two sides and the angle included between them of a triangle are equal to the two corresponding sides and the angle included between them of the other triangle, then the triangles are congruent. So if we consider two triangles ABC, this is triangle ABC and this is triangle DEF. Two sides and the included angle. Now supposing side AB and side DE are equal, side AC and side DF are equal, then the angle included between the sides AB and AC is angle A, and the angle included between the sides DE and DF is angle D. If these two are also equal, then we say that the two triangles are congruent. So we write it down. We have, if AB equals to DE, if AC equals to DF, and angle A is equals to angle D. If all these three conditions are satisfied, then we say that triangle ABC is congruent to triangle DEF, and this happens by side angle side rule, SAS rule. So this is the second rule, congruency criteria, with the help of which we can prove that the two triangles are congruent. Now moving on to the congruency rule number 3. Congruency rule number 3 is ASA congruence criteria or rule. So if under a correspondence two angles on the included side of a triangle, two angles and the included side of a triangle so if under a correspondence two angles on the included side of a triangle are equal to the two corresponding angles and are equal to the two corresponding angles. So if under a correspondence two angles and the included side of a triangle are equal to two corresponding angles and the included side of other triangle, then the two triangles, or you can say then the triangles are congruent. So let us read it out once again. If under a correspondence two angles on the included side of a triangle are equal to two corresponding angles and the included side of the other triangle, then the triangles are congruent. So this is a angle side angle. consider the triangle ABC and the triangle DEF. Two angles. Suppose angle A and angle D. These are two corresponding angles. They are equal, and if it happens that angle B, if this angle A is equals to angle D, and angle B of this triangle is equals to angle E of the other triangle, and at the same time the included side is, so the side which is included between angle A and angle B is AB, and the side which is included between angle D and angle E is the side DE. So if these two are also equal, then we say that the two triangles are congruent. So let us write it down here. So if angle A is equals to angle D, angle B is equals to angle E, and the included sides, that is AB is equals to DE, then if these three conditions are satisfied, then we say that triangle ABC is congruent to triangle DEF, and this is by ASA rule. So this is the third congruence rule or the criteria with the help of which we can prove that the two triangles are congruent. Moving on to the fourth one. This is AAS congruence criterion or rule. If under a correspondence if any two pairs of angles and one pair of sides. So if under a correspondence, if any two pairs of angles and one pair of sides are equal, then the triangles are congruent. Then the triangles are congruent. Let us take the two triangles ABC and DEF again. Triangle ABC and another triangle DEF. Now here we can take any two angles and any of the sides. If angle A, we take it as equal to angle D. This is angle side. The side is not mandatory that it has to be included between the two angles. So it is angle sides. So if angle A equals to angle D, angle B is equals to angle E. And now for the looking for the side, it can be the included side, it may not be the included side. So you can take side AB equals to D, or you can take side BC equals to F, or you can take the side AC equals to DF. So suppose we take side AC equals to DF, then the two triangles will be congruent. So here angle A is equals to angle D, angle B is equals to angle E, and we have taken the side AC equals to side DF. So if these three conditions are fulfilled, then also you can say that triangle ABC is congruent to triangle DEF, and this happens by the rule AAS. So this is another angle side relation. Moving on to the fifth one. Moving on to the fifth one, it is RHS congruence criteria. That is This is basically applied when the triangles are right angle triangles. That means one of the angles is a right angle, that is 90 degrees. So if under a correspondence, the hypotenuse and one side of a right angle triangle, the hypotenuse and one side of a right angled triangle. If under a correspondence the hypotenuse and one side of a right angle triangle are respectively equal to the equal to the hypotenuse and one side of hypotenuse and one side of other triangle, obviously right angle triangle, then the triangles are congruent. So let us take the triangles, two right angle triangles, A, B, C. This is D, E, F. In these two triangles, angle B and angle E are right angles, each equal to 90 degrees. And if you read out this, if under a correspondence the hypotenuse of and the one side of a right angle triangle, that means this AC and DF, which are the hypotenuse of the respective triangles, are equal, and you can take any of the two sides, let AB equals to DE or it can be BC equals to EF, then the triangles are congruent. If you take it as AB and DE, it can be BC equals to EF as well. Okay, so it can be, if you write, if the hypotenuse, that is AC, equals to DF, AB is equals to DE, and obviously angle B equals to angle E equals to 90 degree, then we can say triangle ABC is congruent to triangle DEF, and this is by RHS rule. Hope this is clear. These are the 5 weapons with the help of which we can prove that the two triangles are congruent. One more criteria is there, but that cannot be applied in order to prove that the two triangles are congruent, and that is
AAA.
Yes?
AAA.
Triple A. If it is AAA rule, if we apply this, that means all the angles, corresponding angles are equal. In that case, there is a chance that the sizes may vary. Suppose this is an equilateral triangle. Each angle equals to 60 degrees. But this is also an equilateral triangle whose angles are 60 degrees. Each equals to 60, but you can see the sizes are different. Though their shapes are similar, but the sizes are different. If you go by this angle rule, then sometimes it may not fulfill our requirement. Sizes may vary, but in case the two triangles are of the same shape and same size, then they may be congruent, they will be congruent, but this rule is not to be followed in order to prove that the two triangles are congruent. One more important thing, if this is, we say the triangle ABC is congruent to triangle DEF. So if these two triangles are congruent, we write it like this: ABC triangle ABC is congruent to triangle DEF. One thing to note, the sequence of the vertices is important. If you write here, these two triangles are congruent, if it's supposing that this angle and this angle are equal, this angle and this angle are equal, and this is equal to this, and this side equal, this much, if this BC corresponds to this, AC corresponds to this. If this is the case, and if we write, this is the way to write that the triangle ABC is congruent to triangle DEF, and see, A has to match, correspond to the letter D. If angle A is equal to angle D, then in place of A it has to be D. In place of B, the second position, E has to come because B is equal to E. And in the third position in C, then F has to come, that is angle C is equal to angle F. That means C corresponds to F. But if we write triangle ABC is congruent to triangle FDE, if we write like this, this becomes not congruent. This becomes not congruent. The sequence is important because A has to correspond with the first here angle. A is not equal to F according to the given condition. So this type of statements, if you write, it may go wrong. So better be careful that the sequence matters, the vertices, vertices matters. Though we have explained the things in terms of the angles and the sides, but the position or the sequence of the vertices is very important. When you write that the two triangles are congruent, this you have to take care of. Okay? So by now we have discussed about what are congruent figures, we have discussed about the congruency of triangles and the criteria which fulfills the condition for the triangles to be congruent. So though we have got the 5 criteria or the rules with the help of which we will be proving that the two triangles are congruent. So practically applying all these rules is the basic requirement at the moment. So we will understand this, all these 5. So any one of the 5 rules, if you can prove triangles are congruent, and one more thing, if you can prove that the two triangles are congruent, then automatically all the angles becomes equal. That means the angles, corresponding angles becomes equal, and the sides also become equal automatically. And if you have to further prove, after proving the congruency, if you have to further prove that the two sides are congruent, then automatically you write they are congruent, and you need to write CP/CT as I told you, corresponding parts of the congruent triangles. So since they are congruent, so you can directly write that side AB, supposing you had to prove, say AB equals to DE like this. So this is what is all about the concept of congruency of triangles. Hope you have understood this. Any questions from your side?
Yes, sir.
Yes, tell.
Sir, why we don't use SSA criteria?
SSA criteria does not always fulfill it, because as I told you, all the criteria, that's just like AAA that we have used. If you go by that, in that case the sides, if you are taking, the angle may vary. The angle may not be the equal, sides may be the equal, so the angle may vary. In that case, those two cannot be their two figures may not superpose, or they may not overlap. So there is a probability that the angles may change and the triangles may be looking similar, but they do not superpose. For example, if you take this triangle like this, if we want to put it like this, supposing these two sides are equal, now this angle and this angle are different, so it cannot prove that they are congruent. Even if the two sides are equal, the angles are different. In that case, if you want to overlap one above the other, the triangles will not be exactly the same, and that's the why we don't use this SSA criteria. Any more question? Anything else? Any more question?
No, sir.
Okay. Now today we just running out of time, so we'll just take one example to see how can it prove. Let's take the first question. Question number 1. In the given figure, AB parallel to CD and O is the midpoint of AD. O is the midpoint of AD. So that number 1, triangle AOB is congruent to triangle DOC, and the second part, O is the midpoint of BC. So let us draw the diagram here. So this is A, B, C, D, and this is O. What is given? First you know, in the given figure AB is parallel to CD. So you have put an arrow mark here indicating the two lines AB and CD are parallel to each other. O is the midpoint of AD. If O is the midpoint of AD, that means this side and this side are equal. Okay. Now you need to prove the triangle AOB. That means this triangle and this triangle are congruent. Now if you remember the properties of parallel lines.
Sir, AAS.
If these two are parallel lines, then this can be considered as what?
Transversal.
Transversal. So can we write this angle and this angle as equal angles?
Yes, sir.
Yes. And can we have this angle equals to this angle?
Yes.
Why?
Opposite vertex.
They are called vertically opposite angles. And at the same time, this side and this side are equal. So it is angle side angle, ASA. So we write in triangle, for the first part, in triangle AOB and triangle DOC. The first one we can write angle BAO is equals to angle CDO. The reason you have to write, interior alternate angles. Second point, angle AOB is equals to angle COD. Angle AOB is equals to angle COD. AOB equals to COD. They are vertically opposite angles. V vertically opposite angles. And the third point, which is already given in the question, that is O is the midpoint of AD. So OA equals to OD. And you write it is given. Okay, so finally you can say, therefore triangle AOB is congruent to triangle DOC by angle side angle rule. Second part of the question asked, O is the midpoint of BC. O is the midpoint of BC. Just now, as I told you, CPCT. Now, if you have to prove O is the midpoint of BC, that means you have to prove OB equals to AC. Right? Now, since you have proved triangle AOB and COD are congruent, then automatically OB and OC are also equal. So, you directly write, therefore, OB is equals to OC, and you in bracket CPCT. And this proves your question. So this is how you have proved. This is how you have to write all the criteria and in bracket the reason behind why you are taking the angles to be equal or the sides to be equal. And then finally, and so after proving this congruency, anything you are asked, directly write that is equals to this, and in bracket you write CPCT. Okay, so let us conclude the class for today here only, and tomorrow on the next class we'll be taking up more questions based on congruency of triangles. Till then, you just go through this, just understand this, and if you have got the textbooks with you, you can start solving the questions based on this particular topic. But it will help you if you go through the solved examples first, and I hope you have done it in class 8, I suppose, so it won't be much problem for you. But then we will be discussing in the next class. Till then, have a nice day. Bye bye.
Sir, one question, sir, please.
Okay, tell.
Sir, this can also be proved by AAS, no?
Yeah, AAS is applicable. Angle side is always applicable. There is no problem. Now tell me which one we have to take. Tell. AAS.
Sir, angle B.
Yeah.
Angle C is equal to angle B, sir.
If you take angle C equals to angle B, that is also true, but then it is angle side, right? Clear?
Yes.
Now it is clear.
Yes, sir.
Okay, thank you very much. For today we will be joining in the next class. I will take up more questions based on this topic. Have a nice day.